given. Okay, now I want all of you to come back to the module. In that magnetism, come to page number 52. Module 7, page number 52. Come there.
कैमरा ऑन करो सब लोग। ये आरना विश्वकर्मा न्यू स्टूडेंट है क्या? आरना
Now, if you see module 7, page 52, last class we have done the first page. Just check. Okay, page number 51, we have gone through in the last class. Check. Now, in today's class, we will start from page number 52. Okay. So, the first thing that you have, listen to me carefully, is called pole strength. And you know, pole strength is given by QM. Correct, pole strength from 11th standard, you know, it's given by QM. And you know that the pole strength of North Pole and South Pole, that the pole strength of North Pole is given by plus QM and pole strength of South Pole is given by minus QM. Correct. And I told you the unit of pole strength is ampere meter. All this is there in your 11th. If you have gone through, check.
Yes,
So if you read the side heading pole strength, the strength of a magnetic pole towards itself is called pole strength. Pole strength, okay, of north and south pole is plus QM and minus QM. SI unit is ampere per meter or Newton per Tesla. Dimension is LA. Why LA? So if I take the dimensions MLTA, ampere 1, length 1, there is no mass, there is no time. So this is the dimension of pole strength. And next point, point number D, just check. Pole strength of a magnet depends on the nature of material of the magnet and area of cross section. Not that important, but okay. And pole strength does not depend on length. That is an important point. Point number E. Pole strength does not depend on length. These are all the things you need to know about pole strength. What are the things? How it is denoted by? North pole is what? South pole is what? What is the unit? What is the dimension? And it does not depend on length. So make a note of this. This is already there in your level. But again, make a note. Then we go to the next topic. Start. Written?
None, sir.
And the next topic is one. We have done the electrostats. What is electric dipole? Now I'm teaching you what is magnetic dipole. Now you know what is the meaning of dipole? Di means two and pole is the poles. So when I say magnetic dipole means two poles. Therefore magnetic dipole is two poles, correct? Magnetic dipole is two poles. Therefore two equal opposite poles separated by some distance is called a magnetic dipole. Listen to this again. Tell me, how do you pronounce this? Look at this. Two equal opposite poles separated by some distance, they form a magnetic dipole. So for example, here, if I have one pole over here, north pole, if I have other pole over here, south pole, look at this, and this is a magnet. Now, can I say there are two equal opposite poles separated by some distance? Therefore, this system, therefore magnet, is called as a dipole. That is why a magnet is always referred to as a dipole, because it has two poles. But what is the exact definition of a dipole? It is two equal opposite poles separated by some distance. For example, in a magnet, do I have two? Yes. Are they equal in strength? Yes. Are they opposite in magnitude? Yes. Are they separated by some distance? Yes. Therefore, this system is called as a magnetic dipole. Is it clear?
Yes, sir.
So make a note of this. This is your keyword to remember. Two equal opposite poles separated by some distance. Okay.
Excuse me, sir.
Now, next topic is magnetic moment. Next topic is magnetic moment. One thing about magnetic dipole, no, sorry. One thing about magnetic moment is you should know four formulae already. Do you know four formulae for magnetic moment? Tell me. So what is the first formula for magnetic moment? M is equal
NIS.
to Qm into 2L. One more formula is M is equal to NIA, correct? Then next one is magnetic moment of an electron revolving around the nucleus. We got EVR by 2. And we got one more formula for magnetic moment revolving around the nucleus was EL by 2ME. Check. Fourth formula for magnetic moment. Now, what is the unit of magnetic moment? Can anyone tell me? What is the unit of magnetic
Capital M.
unit? That is notation. Capital M is the notation.
Ampere meter square.
Ampere per meter square.
Ampere
Ampere
into
meter square.
meter square. This is the unit of magnetic moment. Therefore, just check the side heading magnetic dipole moment. And if you see everything, you will get the answer. And it was there in your 11th standard also. It is a vector quantity and it is directed from south pole to north pole of a magnet. That is also there in point number 5. Check. It is a vector quantity which is directed from north pole, south pole to north pole of a magnet. Again, all this was there in your 11th. Now, these two are the general formula for magnetic moment. These two are for electron around the nucleus. Make a note. Written. Okay.
Yes,
Okay,
sir.
Nitya. Now see this. So pole strength, check. Everything clear about pole strength? Everything clear about magnetic dipole? Everything clear about magnetic dipole moment, or it is only called as magnetic moment? Now,
Sir,
if yes,
will you please bring that slide again of pole strength?
yeah.
Sir, just a minute. Done, sir. Thank you.
Now, if you see in same page number, Aditi, so two equal opposite poles separated by some distance. This is the wording for dipole. two equal opposite poles separated by summation. Now, if you see point number 7, combination of bar magnets. Can you see on your point 7? Combination of bar magnets. This is nothing but vectors. So if there are two magnets, okay, one with magnetic moment M1, another one with magnetic moment M2, and they are placed at some angle theta. See the diagram. Okay, point number 7. Then the resultant, okay, that is the resultant angle tan alpha, just check, is equal to, same like vectors formula, it is b sine theta divided by a plus b cos theta. Check, in vectors you have this formula, therefore over here it will be m2 sine theta divided by m1 plus m2 cos theta, and then the net magnetic moment or the resultant magnetic moment will be square root of m1 square plus m2 square plus 2m1 m2 cos theta. Don't you think it is similar to a vector resultant and vector angle? Check, in vectors, what is the resultant vector?
Yes,
Square root of a square plus b square plus 2ab cos theta. And what is the resultant angle? Tan phi is equal to b sin theta divided by a plus b cos theta. Same thing with your bar magnets also. The resultant angle of a bar magnet, that is when two bar magnets are kept at an angle, and the complete magnetic moment, that is the resultant. Okay, start. This is point number 7.
So I didn't understood this.
Have you studied vectors? Have you studied vectors? Who is this?
Sorry, sir, I was not getting network issue. So I was not there for 11th standard.
Sejal, have you studied vectors?
Yes, sir. Little bit.
Tell me, in vectors, what is the resultant vector formula?
So I don't know.
Hmm?
I don't know.
Resultant vector formula is square root of a square plus b square plus 2ab cos theta. Check your vectors, 11th standard. Resultant vector formula is square root of a square plus b square plus 2ab cos theta, and the resultant angle is b sin theta divided by a plus b cos theta. In math, there is, if you have taken math, there is a this thing. In math, there is a derivation also, and in 11th physics, these are the direct formulae also. I think my screen is no longer visible on that.
Yes,
So
sir.
resultant, okay. So even if you don't know this, you should remember that resultant of a vector. Resultant of a vector R is equal to square root of a square plus b square plus 2ab cos theta, and the angle between the two vectors A and B always is tan alpha is equal to b sin theta divided by a plus b cos theta. Now these are the general formula for vector resultant and vector angle. You will have it in every chapter wherever there is a vector involved. So over here, can I say magnetic moment is a vector? Just check, in the previous slide itself, I told you that magnetic moment is a vector. Just check. Therefore, all the laws of vectors will be applicable. Therefore, when vectors are there, so if this is A vector and if this is B vector, and if you look at any vector textbook, okay, 11th standard physics textbook also, you will get same answer for angle and resultant. Now, this values will keep coming in all chapters where there are vectors. Okay, so this format you might have seen in other chapters or not, I don't know, but it's a very common syntax.
Yes, sir.
Okay, Sejal.
Yes, sir.
Nitya, homework questions I will explain after the entire chapter is over. Completely, I'm keeping a session on homework. Now,
So what does mean of that net?
which one?
What is the meaning of that net word?
Net means total. Means net magnetic moment or resultant magnetic moment or total magnetic. This means total net.
Okay.
Okay. Now, on page number 53, you don't need to go to page number 53. I'll do it for you. See here, last year we studied magnetic induction along axis formula and we studied magnetic induction along equator. Correct? We studied these two formulae. Does anyone remember what were the two formulae? Direct formula.
mu naught upon 4
Mu
pi
naught
into
pi
2m
upon 2
2m into r cube.
Remember all this?
Yes.
Magnetic field along the axis was mu naught by 4 pi 2m by r cube. And magnetic field along the equator was mu naught by 4 pi into m upon r cube. And I also knew that magnetic induction along the axis is 2 times magnetic induction along the equator. Make a note of all of this.
So what does that B denote again?
Magnetic induction.
Okay.
And you know the unit of this will be test for per meter.
Sir, your voice was breaking.
Hmm?
Your voice was breaking.
Something will be Tesla or Weber per meter square.
So what is that 2BEQ? Okay.
Is my voice clear now, everyone?
Yes.
Yes, sir.
Now, torque of a bar magnet, look at the screen now. Torque of a bar magnet is M cross B. Or torque of a bar magnet is, what is A cross B formula? KB sin theta. Therefore, this is MB sin theta. And what is the unit of torque? Unit of torque is Newton meter. Because the general formula for torque is force into perpendicular distance, correct? General formula for torque is force into perpendicular distance. Force is Newton, perpendicular distance is meter. But in this particular case, I have to find torque of a bar magnet. Therefore, torque of a bar magnet is M cross B, where M is magnetic moment and B is magnetic field of induction. Therefore, the formula for torque of a bar magnet is M cross B or MB sin theta. Make a note.
So that the symbol of torque, is it an arrow or something?
It's
What
a
is
Greek
it?
symbol tau like this. It is a Greek symbol tau, but I write it like this. Some people write it like this. Some people write it like this. It's a Greek symbol T, that is tau.
Okay.
If you see the module, they have also used the symbol. Just check how they are used. Now, can you tell me when is torque maximum and when is torque minimum? At what angle? Can you think about it? At which angle is torque maximum?
90 degree.
Can I say when theta equal to 90 degree, torque is maximum, and when theta is equal to 0 degree, torque is minimum, because it is proportional to sin theta. Sin 0 is 0. Therefore, torque is minimum when angle is 0, and torque is maximum when angle is 90. Therefore, right now, torque is maximum when the theta or when the angle is 90, and torque is minimum when the angle is 0. Make a note. Written, everyone?
Wait, sir. Done, sir.
Okay, so all of you, Shannon. What time is that? So log off and log in.